Welcome to our YouTube channel, guys. I hope you're doing well, and this is a video after a long time, and we thought and we thought we should do a series on uh, mathematics. So we'll be teaching uh, a lot of concepts, and uh, the number one amongst them will be basic functions, and in and these will be short videos, and these short videos in uh, 10 to 15 videos, this I don't know, in 10 to 15, or I don't know in how many videos this will be over the functions topic. This will not only be basics but advanced as well. uh, uh, Not that advanced, but to some extent. So this is the first topic, that is functions, and after that there will be another chapter. After that, another chapter, so let us begin. What are functions? There are a lot of variables that change as a consequence of another variable changing. For example, uh, because of change in time, some other thing may change. For example, uh, temperature may change because of change in time, etc. And sometimes because of change in position, some other variable may change. And we use functions to describe how one variable changes. How one variable changes as a consequence of the other variable changing, right? So what would be the definition of functions? A function is basically uh, what it is a rule which operates on an input, and it produces an output, but it produces only a single output. Okay, this is one definition. And the other definition that we may uh, you know that we uh, that we may write or remember, that is uh, but it is related to the set theory. We don't need to remember it. The first definition is enough, but this one as well, we can say it is uh, a function is a rule which operates on a set uh, uh, it operates on a set on every element of one set, and gives uh, 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 and relates it to a unique element of the other set, and relates uh, I mean it relates every element of one set to a unique element of another set, right? I'll write those two definitions, and you may understand. These definitions that I have written on this paper, on this notebook, these are the two definitions that I was talking about. Number one, you can see it is a rule that operates on an input to give a single output. Number two, it is a rule which relates every element of a set to a unique element of another set. These sets you don't need to worry about. You don't need to study set theory, etc. When the time for that comes, I'll upload videos for that too. But functions, I thought, is of the utmost importance, which should be taught first, and other topics after this. Okay, so what we understand from this is uh, it is a rule which operates on an input, so we have to give it an input, and it will produce a single output, meaning uh, if uh, if one element goes through this, if one input goes through this rule, there won't be two outputs, there will be only one output. Okay, and this uh, uh, and this one, according to this definition, it is a rule which relates every element of a set to a unique element of another set, meaning if there is one set, all the elements should be related. Okay, not even one should be skipped. I'll make you understand what this is. To a unique element of another set, meaning uh, for example, if we uh, look at one if we look at a single element uh, of for example, I'll show you with an example. For example, this is a set. Okay, this is 1 2 3, it has three elements, and this is another set. And we have to for example, this is 7 8 7, not okay, 7 8 5. Okay, these are two sets. For example, we have to uh, you know we have to make a function from this set to this set. Then the word every means, for example, one should be related to some element of this set, two should be related to some element of this set, and three should be related to some element of this set. This is which relates every element of a set, meaning of this set. And I'll show you what this is. 1, for example, to 8, 2 to 7, 3 to 5. So every element, 1 got related to some element of this set. Okay, 2 also, 3 also, and these elements are unique, meaning one did not get related to 7 as well as 8. Okay, for example, this is a function, this is a function from, let this set be set A and this set be set B. This is a function from set A to set B. Okay, but if we now for example if you now for example have it like this, 1 2 3, similar sets, I mean set A and set B, again. Okay, 7 8 5. Okay, one is related to 7 and one is related to 8. Okay, 2 is related to 5 and 3 is related to 5. Okay, so let's begin from 3. 3 is related to 5. Okay, fine. 2 is related to 5. Okay, fine. But 1 is related to two elements, 7 and 8. So this one is not related to some unique element, it is related to two elements of set B, set A, set B. So this is not a function from A to B, because the uniqueness factor is it is not there. This uniqueness factor is not there. So if we now look now I'll give you another example of these same two sets. So this was the uniqueness factor violated. Now I'll show you how the every factor gets violated. So this is not a function, not a function. Okay, now I'll show you how the every factor gets violated. So same sets here, A and B, set A and set B. Every factor, for example, 1 is related to 7, 2 is related to 7. Okay, and 3 is left alone. So this is not a function because the every factor is violated. Since this every factor is violated, so this is not a function. So every element of set A should be related to a unique element of set B, and uh, hmm, uh, this unique element does not mean that uh, you know it should be related to the same element. For example, uh, all the elements, for example, here 1 2 3 should be related to, for example, 8 only. Uniqueness is not that. Uniqueness is uh, one element should be related to only one element, not two or three elements. Okay, this is how I show you it by how I show this by sets. But this is not important. You may skip this portion. What is more important is what I'm going to show now. Okay, so now I'm going to show you this one. This is better. Okay, this is the input, and this, you know, this is rule. Operates on the input, provides an output, and as I told you, single output. Okay, meaning an input should not produce more than one output. If it does so, then it is not a function. Okay, so let's move forward. For example, I can show you like this also. Input function output. Okay, is this clear? So this is what how a function works. This is very important. And now I'll show you, for example, how these functions actually work. So what is a function? Function is a rule, and remember this, it's a rule which produces a single output. Okay, now I'll show you how these uh, functions work. Okay, for example, I'll show you um, you know for example, I'll show you this one. This is 3. Okay, then I'll show you x here. Uh, 3 6 2x. Okay, I'll explain it in a while. Output. So this is 3, this is x, this is the input box, and this is output box. 6 to x, double the input, is the function. Let us name this function f. Okay, so what is the function? It is the rule, as I you know as I uh, as I have shown you. This is function, input, rule, output. So what is this function? It is actually the rule. Input, rule is the function. Okay, output, input, rule. What is the rule? Rule is actually the function. Okay, double the input, it's the function. And what here we have named the function f, and output. Look, uh, if the function, if the rule is double the input, then 3 should produce 6 and x should produce twice x. Okay, so this is clear. So the what's the function? uh, Double the input. Okay, now I'll show you how this is written, and I'll show you how this is written. But look, 3 is an example that I have shown you. It doubles the input and produces, if you double the input, it produces 6. X is uh, a general, it's a variable, it's a general case. Anything you put, it gets doubled. X twice x, it's a general case. I'll also show you in a while how these are written. So the name here, the symbol for the function here has been given f. We can give other symbols as well, g, p, anything. So here I have written an example. Input, and function is square the input and subtract 2 from it, and then you have to get the output for the inputs 4 minus 3x and t. Okay, for 4, what would we get? Square the input, that is 4 4 square, and so let's do for 4, it is 4 square. And subtract 2, that is 4 square is 16 minus 2, that is 14. Okay, let's do it for this minus 3, and that is minus 3 square minus 2, that is 9 minus 2, that is 7. Now for see, look, here we have to use the input x, so square the input, meaning x square, and subtract 2 minus 2. It is how it's done. And for t, use the input t, that is t square, subtract 2. Okay, look, take a look at this page. This is the most important page of today's lecture, and uh, let's move forward now. Now I told you that I would show you how to write these, in how we write these in mathematics. So look at this function, for example. This one, which one? This, double the input. How we write this? We commonly write this as, I'll show you how. Double the input. Okay, double the input. Wait, if we have this, double the input, we commonly write this as, f of x, this is read as f of x is equal to 2x. This is how it's written most commonly. Okay, it means that if you this in the brackets, this is the input. If you put an input x, a general input x, the function f operates on it and it doubles that input. The output is on the right hand side. Okay, so the input is here and the function f operates on it, and the output is on the right hand side. That what it does to the input, it doubles it in this particular case. Now this is another example. Okay, we have to state the rule, the here the function is given in mathematical form, and now we have to state the rule uh, that is defined by by these functions. Okay, so the first part is f of x is equal to 6x. uh, so the function is f, and the input is x, and the output is uh, multi you know uh, multiply uh, this input by 6. Okay, we can write this. This is the first one. This is very easy. The second one, in the second one, the input is t, function is f, and the output is multiply the input by 6 and subtract it by 1. Okay, okay, multiply the input by 6 and then subtract 1 from it, and this is pretty easy. And the third one, here look, the function is named g. So this is, you can name the function by any letter. And g, the input is x, so what's the output? It's square the input and subtract 7 from that. Okay, look at part D. This is very easy. Function is h, the input is t. What's the output? Q, uh, you know uh, it is cube this input, cube this input and then add 8. So here it was, function was h and the input was t, and the output was cube the input and add 8. And e is, it is only the letters, and the variables are different, otherwise the function is the same. I mean, output is the same. The function is p, the variable is x. I mean, the input is x and the output is, cube this input and add it, the same. So what we learn from this is, in particular from the parts D and E, what we learn from these is that it's not the uh, letters that are important in these. I mean, it's not letters used to define these functions that are important. Okay, but what's important is the function itself is important, not the letters that are used to define these functions. Okay, let me repeat once again. It's not the letters used to define the functions that are important. Okay, it's the rule that is important. Okay, and with this, we end. Okay, and we'll meet in the next lecture, and like and subscribe. Goodbye.